bother you, but I need some help finding zeros of polynomial functions with and without imaginary numbers. And I really need your help because I've never been so good at math. Please help me.
So to start off, we will use the rational zeros theorem to find the zeros of f of x equals 2x cubed plus x squared minus 13x plus 6. Because the leading coefficient is 2 and the constant coefficient is 6, the rational zeros theorem yields several potential rational zeros of f. Next, we find all the factors of the constant coefficient 6, which are positive negative 1, positive negative 2, positive and negative 3, and positive and negative 6. And then we find the factors of the leading coefficient, which is 2, and its factors are positive negative 1 and positive and negative 2. Next, we put each factor of 6 over each factor of 2, which gives us both positive and negative of 1 over 1, 2 over 1, 3 over 1, 6 over 1, 1 over 2, 2 over 2, 3 over 2, and 6 over 2. And we can simplify these to positive negative 1, 2, 3, 6, 1 half, 1, 3 over 2, and 3. The following step is to eliminate the duplicates. So we see that the possible values are now positive negative 1, 2, 3, 6, 1 half, and 3 over 2 because we eliminated the 1s and 3s. Then you have to take all the values we have just found and substitute them in for x in the function. If the output is 0, then that means that the x value is 0, the root, or the x-intercept of the function. And here we see that the values negative 3, positive 2, and positive 1 over 2 have the outputs of 0, so that means that they are the zeros for the function f of x equals 2x cubed plus x squared minus 13x plus 6. And that's the rational zeros theorem. Do you get it now, Roby?
Oh, I get it now.
Roby, what are you doing? We're not done yet. We still have to find complex zeros.
Oh, yeah.
Here is an example of a problem for finding complex zeros of polynomial functions. The problem is 2 plus 1 is a zero of polynomial p of x, given below. Find all the other zeros. Since the 0, 2 plus 1 is an imaginary number and p of x has real coefficient, it follows that the conjugate 2 minus 1 is also a zero of p of x.
Wait. So if a and b are real numbers and a plus bi is a zero of f of x, then its complex conjugate is a minus bi and it's also a zero of f of x?
Yep, you've got it. Those are complex conjugate zeros. So now we know two zeros of this polynomial function. We should also keep in mind that p of x is a 4th degree polynomial, so it will have at most 4 zeros. We only know 2 right now, so we have to expand the terms 2 minus I and 2 plus I and multiply them together in order to find the other zeros of the polynomial function. After multiplying, we get x squared minus 4x plus 5. Now to find the other zeros, we divide the polynomial function by x minus 4x plus 5. And the quotient we get is x squared plus 2x minus 3. The remaining two zeros of p of x are the solutions to the quadratic equation. So we have to factor x squared plus 2x minus 3 and solve. The solutions are x equals 1 and x equals negative 3. Finally, we figure out that p of x has the following zeros: 2 plus I, 2 minus I, negative 3, and 1. That wasn't too hard, was it, Roby?
Nope, I got it now.
Really, Roby?